Hey guys, I'm Joseph Little. I'm here presenting this webinar today, the second in a series of three that will focus on full vehicle analysis for SAE competition, focused on formula, but it's fairly broadly applicable to the other disciplines as well. So I'm a formula, about me, I'm a Formula SAE graduate. Did formula for pretty much all 4 years of college. I wound up as chassis leader about halfway through, and also I guess like Adam's guy on the team. I did that. I participated. We competed in a few times here in the States. Weren't quite big enough to go international or anything, but we had a car. It ran. It did pretty good. I did that for a few years. I got into Adams, got really into Adams. And then I got connected with, it was MSC, it's Hexagon now, but MSC made Adams at the time. I was hired by there. I moved to Ann Arbor, and I supported the automotive. I became an Adams car tech rep, and I supported Adams car in the greater Detroit area for a while. And I also did a lot of work on developing materials for Formula SAE while I was there. I then went to work at Chrysler, about the time I was acquired by Fiat, so Fiat Chrysler Automobiles, and I worked in virtual tools development there to develop their simulation processes, mostly Adams car based. I sat in the chassis team, so I was with the chassis guys, but I supported also their durability guys for load generation. Somewhat rusty. And then I did that, and then I went off and didn't use Adams car for I took another job doing Adams View in biomedical industry. So I spent like 6-7 years not touching Adams car, and now I'm back at at Hexagon now. I'm in services, so I'm not specifically Adams car focused now. I do use Adams car for some special projects. The thing here is I'm a little bit, you might recognize in this presentation, I'm a tad rusty with the interface because even when I've used it recently, it's been like mostly custom interface stuff. So you have to bear with me, but I think I got it fairly, I think I've shaken off most of the rust in that regard. So I guess, why Adams? Why a student should you be looking at Adams, right? It's a dynamics tool, or the proper terminology is multi-biodynamics simulation or multi-biodynamic systems, which is the more classic term would be like rigid body analysis. It's a physics tool, it's a dynamics tool, and it has a car interface. It's not like a black box car tool. So what that means is that you could simulate any system, any dynamic system you want in Adams. Whether it be the view interface or the car interface, they're actually the same. You can switch between the two, you can. It's not black box. There's nothing every single part and body on the car is there. You can right click on it. You can edit it. You can delete it. You can make a new one. There's no the basic outside of very limited number of systems. Nothing's compiled in code that you can't read or modify. In fact, and the modification of the vehicle doesn't require coding, right, at all, because it's a whole user interface. So compared to some of the, I've used a lot of other tools too. I've used CarSim a fair bit, and I used WinGeo back in the day. I didn't use OptimumG. I know it's popular. A lot of other tools for both suspension simulation and full vehicle simulation are black box. Like we say black box as a mildly, I guess, derogatory term, but it's not. They have their uses. They're great. But Adams is, you can do things they can't, right? Is the main deal. And then that's kind of like the sell of functionally why you should use it. But why you personally might want to use it is that the majority of passenger and commercial vehicles, in the entire planet, majority, not even a slight majority, but probably 80-90% of the wheeled vehicles on the planet had the Adams was their primary chassis design tool, and probably also the primary loads prediction tool. There's a few competitors out there, but we're Atoms is almost ubiquitous in the space. Even if it's not Atoms car, a lot of them are Atoms-based tools. And then some of the other competitors out there are very similar to Atoms, so much so that like Atoms in many cases, even if they don't use Atoms, they'll accept Atoms experience as equivalent, as an alternative to the tool they actually use. In addition to automotive, it's widely used in air, space, biomedical, energy, and defense as well. All of these, pretty much all of the major mechanical industries that make things that move, use Atoms quite a bit at the high level. And so you as engineers, right, if that's what you want to do, then Atoms is a great way to get your foot in the door to those career paths. So this presentation, I kind of the kind of idea here. This is not going to be like a it's not a training exercise so much as it's a for the people here that are with us live. I think it's more of like a top-down overview of what an overview of how I expect you to use Atoms. If you get into Atoms and you use it for a good bit, I'm trying to provide you a preview of what that's going to look like today. It's sort of a top-down overview. There will be some examples, and especially when you watch this, when you rewatch this and you watch the recording of this, there will be some demos and examples you can follow along with. But for most of the actual training and examples, I will refer you to the tutorials and examples that are available. There are some you can access from Atoms itself. There's getting started with Atoms car is a good one that's built into Atoms. So if you have Atoms car, you can open that. There's a bunch of examples in there too. And then you can see here in this little help menu, it can send you to Atoms Forum and Atoms Sim Companion. And then there are Alex will tell you more. Alex is the host of the meeting and our academic coordinator. He will tell you more at the end of the presentation about how to access the other materials. There's like a 2-day, or I say 2-day, don't quote me on that, it might be 1 day, 8 AM 743 Formula SAE training set of materials that will take you a whole day to go through, and it's got several materials. If you were in the previous webinar, you might have been exposed to that. And then there's also just, there's training for every Atoms product as well. If you gain access to that, and that's, there's pathways for students to do that as well. But for this presentation, I'm going to be trying to provide you that overview of Atoms usage. So what we're going to talk about is I'm going to talk about what models exist that are available to you and that you should be interested in, focused on. We're going to talk about full vehicle configuration. It should say here, but this, all this is in the context of full vehicle analysis. The previous session was focused on suspension, and the next section will be focused on some advanced topics other than full vehicle. But this is all full vehicle. So the configuration of the full vehicle and a few sort of systems, I'll use as a broad term, that are relevant to somewhat understand to be successful at full vehicle simulations. And we'll talk about roads and tires real quick, and then we'll talk about events, which is like the meat, right? That's what people are trying to do, simulate events. I will sort of break those down into a couple major categories, so you can have some context to where to look, and then we'll talk a little bit about the driving machine and the post-processor, and then briefly touch on some advanced topics. We'll talk about scripting a little bit. Okay, vehicle models. So the model we'll be primarily working with today is the Formula SAE database. I'm going to assume that either in the previous session or in some other materials, the way to actually install it, put this database on your machine and connect it to Atoms car. I'm not covering that here. It's not, you'll have to. you'll have, I would refer you to training material or other session to figure that out, because I'm not going to show that here. It's already set up. But once it's already set up, you can go here and you can go to File, Open, Assembly, and we'll be opening the full vehicle assemblies. And you should come in here. You should see Formula SAE 2021 or whatever year it happens to be when you're checking this. And you click into here, and you'll see that there's 2 suspension assemblies and there's 2 full vehicle assemblies. And we'll be working with the full vehicle assembly today. I'm not going to open it; it's already open. But that's going to be primarily what you see in the background. But there is a Baja model as well that's available on the Sim Companion, and also the other models that you'll see in here are the shared. So you'll see A-car shared and you'll see A-car concept. These are the default models that come with Adams, and then you'll see this MDI demo vehicle, and LT is just the same vehicle without graphics, but they're essentially the same. This is our primary sort of demo vehicle that we use to demonstrate functionality all the time, and I'll just actually open that up. So, this one, if it opens, I think I do this film. Things are shared. Yeah, demo vehicle. Fine. Just open that up. We probably won't do much with it, but just know that it's there, and there will be times when you find it helpful to open this. If you're trying something that doesn't quite work right with the formula model, you could come over here and try to do it on this model as a sanity check. It's a very different vehicle, so it won't always, the parameters are different, but it does exist and it is useful to know about. So you have that, and there's several other vehicles there in the shared database and the concept database, and I'll let you navigate through those. Just know that the key takeaway here is that the demo vehicle, the MDI demo vehicle, and A-car shared is kind of the premier example model that gets delivered with Adams, and is going to be the most robust of the different models. So now I want to talk about configuration of the full vehicle. So I'm assuming that configuration of the subsystem and the half cars has already been covered, or you've read about that in other materials. When you load up a full vehicle, a four-wheel vehicle that's not hooked to a test rig or anything, there are a few specific configuration panels that you want to be looking for. You will have already seen the hardpoint table from the subsystem session, and this is the same here. You can pick all of the subsystems. Obviously, there's more subsystems here. There's a chassis here, which wouldn't be in a half vehicle assembly, and then there's actual assembly. You can switch to it from between assembly and subsystem views, but those are all pretty straightforward, right? It's hardpoints. These control all of your sort of key Cartesian points in the model, and all of the elements have been all the elements that you would expect have generally been constrained to follow hardpoints. The other table here is parameter variables, which you probably should also be familiar with from the other session, but if you go to parameter variables table, so parameter variables will be data that isn't a Cartesian point, right? So most of these are going to be floats, just various values that is needed, but there's some strings, there's integers, and there can be strings. I don't think there are any string variables in this model, but there's just random variables that are important to the model and have been parameterized to be used by something, or can be found in this table. The other two sort of points of interest in the adjust menu are the shift, which you might have saw previously. It's a you could just move. You could just physically move you could physically move whole subsystems from in Cartesian coordinates. And then we got the adjust mass tool. is you can use this to adjust the mass. So that covers the adjust menu, and then to go a little bit deeper. The main reason I'm covering this, like you could obviously go into these menus yourself and just start clicking around. But if you'll notice, I only covered about 1/3 of these options because a lot of them are not. A lot of them aren't applicable because they don't. They may or may not be set up to work with this database, right? So just be aware of that. Yeah, so just be aware of that. I'm covering like the key points in this menu, and then also, is the layout sometimes of all of the different tools are not initially intuitive. So there's actually more adjust features here in simulate full vehicle setup, right? Which may not be immediately apparent. And then if we go into here and I'm going to like set powertrain parameters, we'll get a nice little menu that allows us to configure the powertrain and set all of our shift points. And then if we click here, we can look at our shift power map, stuff like that. So the key there's inside that vehicle setup menu, there's the powertrain parameters, there's the full vehicle parameters, which is kind of maybe a vague name, but the full vehicle parameters menu lets you set up your steering and braking ratios. Now, these values that you set in here, they are the same. A lot of them are the same, if not all of them are the same as the ones you can modify in the parameter variable table. But these are just, this is just a little, a streamlined, more customized interface to access those variables. And so it's always, if you want to check if they're exactly the same, it's easy to change them here and check another. But it's just a more streamlined way to change these variables. And then we have the other thing of interest in here, and yet another top level menu is model diagnostics aggregate mass. It's sort of buried in here. That's pretty useful. You can open up this aggregated mass tool. You could select all for bodies, and you can hit apply here. And this will tell you the variety of information about the total mass of the vehicle. And then for your tires and wheels, yet another way direction to access that information from is to actually just you right click on the wheel themselves, and that is how you get access to tire data. So this is just a selection of the tire property file, and then some basic information about the wheel itself. And we will talk about, I won't talk about the tires that much today, but that will be covered in the next session. Obviously, tires are very important. But these tire property files will be covered a little bit later on. So those are so I think I've done a pretty, like, if you have to know about, this is kind of like the key set of places you want to sort of move through when setting up your vehicle. It's probably not entirely exhaustive, but I think I've hit all of the main ones. If you go outside of this, feel free to check it out, of course, but you might encounter things that may or may not be compatible with the Formula database, right? So moving on from configuration, let's start to talk about the events themselves. So the full vehicle events in Adam's car can be accessed as shown. You do, simulate full vehicle analysis, and here they are, all laid out. There's a lot of different options to pick here, but and they're organized here. But I would break them down into 4 main categories. There are the non-road events, which include there's a durability rig, which is like a 4-post analysis in automotive parlance. There's a KNC rig and a tilt table. You guys are probably familiar with that if you've interacted with the motorsports world at all very much. I'm not going to talk about those much today, but they do exist. Then there are what I'll refer to as canned road events. So canned is like sort of pre-made events that are all but narrowly defined, and you just got to pick from a limited set of options, and it runs the event. And then those I would break down into 3 categories. There are the static and quasi-static events, and then there are I would say there's I would lump together straight line and open loop steering events. These are events where you may or may not have throttle control, but the steering control is either open loop, meaning you tell the steering exactly what to do, or you just tell the machine to keep the steering straight. And then the third category of canned events I would call the closed loop steering events, where you tell it a holistic goal for either you either tell it lateral velocity or you tell it radius and forward velocity, and it uses closed loop methods to achieve those. It's not a hard and fast, way to break them down, but I kind of think of them as in those 3 categories. And then you get into, I would say, smart driver and path optimization is another category of events, and that is a category of events where it's like a course. It's trying to go through a whole course, and then there is a process by which it tries to figure out the controls to navigate the entire course. And then the last topic I would say is event builder. And event builder is kind of like the kind of everything here, all the canned events and smart driver and path optimization, they're all a simplified alternative to event builder. Event builder is often billed as a more advanced tool, but you don't necessarily need to be very advanced to use it. I would say that for anything you're interested in, the canned events are kind of your starting point, and you'll use the canned events as long as they work for you, and then you'll probably move out of canned events into the event builder. Not very far into your usage of atoms, depending on how particular you want to be about your events. And I'll demonstrate both canned events and event builder later in this session. But first, let's talk about some basics. I'm going to pull up one of these analysis in just a minute and run it for you. And you don't have to try and read. You don't have to try and read these events here. I put these 3 events here for this graphic is a little bit out of place, so I have to fix it. But this is just supposed to show my ignore this little flask that's totally out of place here. But these 3 events are you don't have to read. These are just for you to refer later. These events all run, right? So with the formula car, you load the formula car up. If you fill out these 3 events, the single lane change, which is an open loop steering event, the straight line acceleration, which is a straight event, and then the I got single lane change in here twice. I'll update this. The third one should be skid path, not single lane change. I'll update those and before we upload these slides. And it's just examples of how you fill it out. One thing is that, like, when you first open these, if you just leave the default values and you hit apply, oftentimes the simulation will fail. And I think I'll probably demonstrate the simulation failing. You got to give it realistic parameters for the Formula SAE car for it to run. And that usually involves, the key thing there, that's if you experience a failure when you try to run one of these events, that's often it's velocity or gear. Those are the 2 kind of main culprits. But it could also be that you've asked it to achieve, a lateral, a turn radius or a lateral acceleration that's not realistic for the vehicle. But these 3, if you pretend that single lane change actually says skid pad, these 3 events are like a good little spread of events that you might be interested in terms of simple events. And these will serve as 3 examples of starting points where it runs, and you can move from there towards where you want to be. So what I'll do now is I will open this up and run set events. Simulate. So I've already opened you open atoms, and I've already opened the I've already opened the car. I've already ran the events too, which you can see down here, but that's not necessary to, at this point, it would not have been necessary to run it for you to follow along here. I will go to full vehicle analysis, and let's do the straight line events acceleration, right? So I've opened up acceleration, and to help remind myself, I am looking over on my other screen at the straight line acceleration example, just so I can remember what all the numbers are myself. And so I'll type in, to run an analysis, you first just type in something to this little prefix box so that it has a prefix for the simulation. And then you pick how long you want to run, which requires some intuitive understanding of what exactly you're trying to simulate. Like, you know how long it takes your car to top out, right? So take your best guess at that. And then for number of steps, I like using step size. Just makes more sense to me. I like 05. I like 20 frames per second output. Now, this step size right here is just it's output step size. It's not solver step size. Solver chooses its own step size based on the dynamics of the system. I won't get into that, but for the Formula SAE model, it's probably making its own selection of step size pretty intelligently. But this is just going to show, this is going to be your step size in terms of your plotting and your animations coming out the other side. If you want it to run, you should be interactive mode, not event only. This is where you pick your road. For most of these examples, we'll just be using this default flat road here. And so I'll just look at my, if I just look at my straight line acceleration settings, I have 10 miles an hour, second gear, and then I'll look at these start times right here and fill those out. So it is 10 miles an hour, second gear. It is important you start in the right gear, obviously, just like in real life. So if you click this little icon, it will look up the velocity in your speed map, and it'll give you some hints. It's helpful. But it wants me to go down to 1, but I have to notice the event runs better at 2 from trial and error earlier. And all of the other parameters, I think, are the same. I'm just going to run it for, I'm running it for, yeah, I think I only ran it for 3 seconds before. So I've named this as test, the test prefix here, and then I'll just hit apply. I've already ran it. This is just telling me that the files are already in my working directory, which is fine. I'll overwrite those, and it runs it, right? So this, it happened really fast. This model, they're all rigid bodies. The models run really fast. At least, if you're comparing, like in the context of like FEA, it runs fast, right? And so you see here, it ran. It ended in a maneuver is finished, simulation is complete, which is what you're looking for. This warning looks concerning, but it's not. It's just telling you the sensor halted it, which is fine. That's what we wanted. The time sensor triggered and stopped the simulation. And that's a successful simulation. We can, if we want to do a really quick analysis, if we want to see the simulation really quick, we can just go to review animation controls. And we can hit play here, and we see our car is driving down the road here. And that's how you run a simulation. I will dig a little bit more into that in just a minute. But first, I want to talk about the setup, quasi-static and quasi-static setup. So anybody that's familiar with any simulation tools, you know that before you do a dynamic simulation, you usually do a static simulation. Not always, but you usually do. And this is no different. Before each atom's simulation, it performs a static simulation. And in this case, and in some cases for like a straight line acceleration, it's just setting it up at the initial velocity. Yeah, it's just, so it asks you what the initial velocity is, and at time equals like the very first frame simulation, it's already going 10 miles an hour. The wheels are already rolling. There might be like some slight settling, but the vehicle is pretty much already settled. And that happens by atoms in the background. It performs a quasi-static simulation. And if I look at my message window from my simulation I just ran, and you look at the very top, you'll see this begin static solution, right? The static solution has converged. So it performed a static pre-phase maneuver, and it was successful. Understanding the quasi-static, even though for these CAN maneuvers, the quasi-static setup does sort of happen in the background, but it is important to understand what's going on with the quasi-static maneuvers, because they can often, be the reason your simulation fails. So when I say static and quasi-static, it's kind of a troubled term. In many contexts, quasi-static means it's moving, but it's so slow it might as well be static. That's not what quasi-static means here. Quasi-static in the context of atoms means that it's a static simulation, which means that time is not passing. But we've emulated dynamic forces in the model to prepare the model for dynamics. That you might argue that a better name would be a pseudo-dynamic simulation, but for whatever reason, due to historical reasons, it's called quasi-statics. And in atoms, there are a few key types, which you could look through these. They're also described in detail in the help, which I'll show you the help documentation earlier in a minute for the driving machine. But just know that, like, normally for a simulation, you're either going to be doing the straight quasi-static pre-phase simulation, which emulates a vehicle going forward at a certain velocity and maybe or may not be accelerating at all, or a skid pad, which just emulates cornering condition. So normally, like for the straight analysis, it just happens in the background, right? You don't even know it's happening. For other events, it will give you options of how to set it up. So here, here it asks you if you want to do it or not. So if you turn it on here, it'll tell you, anywhere it says initial is basically what it uses to solve those quasi-statics. But in a minute, we'll look at the driving machine, and I'll show you that that you can actually change it to whatever you want using the event builder. But before we get to that, there is a way. So if you want, you can do a standalone quasi-static maneuver. So if you go to simulate full vehicle quasi-static maneuver, and we go to constant velocity cornering, you'll see this little menu. So when I say quasi-static simulation, I'm usually referring to the simulation that happens before an event, but there is a dedicated, like, standalone quasi-static event, and this can be useful. To sweep quasi-static parameters and see how the vehicle responds, and to help you understand quasi-statics. But just know that when most people talk about quasi-statics, from a thing that happens before a different maneuvering. But I will run this quasi-static cornering real quick. So what it's going to do is it's going to start at 10 miles an hour in the second gear. I know from earlier that 10 miles an hour in second gear is a decent starting condition for my vehicle in terms of forward acceleration. And then I'm going to have my vehicle sweep up to 1.0 lateral Gs, right? So what this is going to do when I hit apply, again, it's going to run a series of static simulations. So normally it just runs one. But when I reuse the standalone quasi-static simulation, it's going to sweep simulation from 0 to 1 across 30 steps. So that has not been successful for some reason. Let me actually look at my own materials. Oh, I think it's the radius. Okay. So I'm actually going to follow my own advice and look back and just take the values directly from the slide. So if I do that, then I know it might be hard for you to tell, but this one is the real one, and the one to the right is the one I'm referring to from my slides. And so if I set up for 8 meters turn radius, and I set up a final lateral acceleration of 1.0, and I think 60 steps is what I did it last time, and same road, and hit apply. This should be, and you got to do a prefix, and it's got to be it needs a prefix, and it's got to be a unique prefix, which is annoying, but it can keep you from overwriting your analysis. And it's solving, and we just saw a bunch of simulation. We just saw a bunch of we saw a bunch of static simulations just fly right in front of us. It's performing the static simulation 60 times. And then if I go into the post processor right now, so I hit you can go to the post processor here, but you see the shortcut's F8, so I just hit F8 and I can go to the post processing window. And I do have a slide talking about the steps I'm taking here to plot things in the post processor, but for now I'll just show you what I got. Which one is it? I think I loaded it on animation. So you can see here I'm loading the animation, but I ran 2 static analyses. I think SSS is the abbreviation. Yeah. So you can see, okay. So you can see the car here. It just looks like it's spinning in place, right? So this is not a time domain simulation. This is a series of static simulations where the car is essentially in like cornering equilibrium at a variety of lateral accelerations, starting at 0 and then going up to 1 if the vehicle can actually sustain 1 Gs. And then if I hit play, it looks like an animation, right? But this is not. Oh, let me slow it down. So we actually see it. This is not in the time domain right now. The dampers, no damping. It's not time domain, but it is sort of like cornering equilibrium, which is almost an oxymoron, but it's cornering equilibrium at a variety of lateral accelerations, right? When you set up a simulation, it only does one of these based on what you tell it you want the lateral acceleration to be. But this is a useful tool, right? Like if you might be interested in your vehicle's lateral handling profile. So actually doing the simulation is useful. Like in car design, people run sweeps of lateral quasi-static simulations. So this is directly useful for diagnostics and analyzing the vehicle performance. But quasi-statics is even more broadly useful in that it happens even before dynamic events. It happens before every event. And I just wanted to sort of give you an intro to quasi-statics, and I wanted to clarify that standalone events do happen, but quasi-statics always happens before even dynamic event. So we can move on from that. I think I covered everything. There's a couple different quasi-static sweeps you could do, and here's one example that works, and you are welcome to play around with the parameters to see about getting the other to work. From experience, it's almost certainly having to do with either turn radius or velocity or lateral acceleration that it has trouble achieving if it fails, right? Usually when Adams fails a static solution, it's because you asked it to do something that it can't do, right? So from here, I want to talk about the driving. Let me check the time real quick. Okay. I'll briefly talk about the driving machine and the smart driver. Actually, I'm going to gloss over this. The driving machine is the set of actuators that control the vehicle. They don't have graphics usually, so it's hard to see them, but in your model, there's almost like a hidden subsystem. It's called in the model, it's called a test rig. So that whenever you pick all of your subsystems that build up your car, there's an extra test rig. There's an extra one you have to pick called your test rig. And so the things that control your car, they're not coded, they're not compiled in C or anything. The controls for your vehicle are actually in the model. You can click into them. So I say they're hidden because if you expand this, they're not here, right? You don't see it in this view. So in a sense, they are somewhat hidden. But if you do tools, database navigator, and you expand your vehicle, and you see the test rig, you can look inside the test rig. The elements are all there as part of your model, and so the test rig is what controls the vehicle. And then you'll hear several terminologies. you hear it referred to as a test rig in general, or in the specific name is NDI test rig or NDI SDI test rig, or is what you'll see it referred to as in Adams, and it's the set of actuators and signals that run the car. You'll hear this other term, smart driver. Smart driver is a tool that makes a reduced degree of freedom model of the car and uses it for path planning. So one thing that a lot of people get caught up on is a lot of people will use driving machine and smart driver interchangeably. They're very different, but a lot of people, if I hear somebody older than me say smart driver, I usually just assume they mean driver machine. That's because I think the terms used to be back, it used to be all the same at some point, but now they're different. So just be aware of that. Don't be confused by that. And then the driving machine is kind of hidden from you until you go into the event builder. And then once you get into the event builder, you'll see all of the knobs for the driving machine exposed. I am going to talk about the event builder here in a second. Really briefly, I want to touch on tires and roads. My colleagues are going to talk about tires in the next session, particularly like tire fitting. But for all these simulations you see here, it's like a flat 2D road, and we're using what's called a handling tire, which just means it's not an off-road tire. It's a handling tire or an on-road tire or a pavement tire. The projected tire models are one of the most common ones, but there are simpler ones, and these are usually fed. You guys will, people in Formula SAE will have access to the Tire Test Consortium. That data available from them can be fit in the tire models using tools that are built into Adams. Again, that'll be covered in the next session. There are also 3D roads, and there's 3D tires for doing off-road analysis. If you have the Baja student, there's mesh-based roads that can have whatever shape you want them to, and then you could use 2D tires with 3D surfaces, but it won't have a high fidelity sort of interaction with small elements. And then if you really wanted to do is this pothole going to deform my rim, you would want to have like a 3D surface, and then you would want to have a 3D tire, a discretized 3D tire, all of which exist. It's not working out of the box on the Formula SAE model, but there are teams that have 3D tires of their Formula model. So I've already done a demo event, post-processing. Let's jump into the event builder real quick before I go back to post-processing. So the event builder is this thing that I've been referring to quite a bit. I think it is a more advanced thing. You don't want to go straight into the event builder, but I do want to touch on it because it is kind of buried in here. Like you'd be forgiven for spending a lot of time in here and not realizing that this little option here at the bottom is one of like the the central building blocks of Adams car usage, but it is. So I'm going to open up this event. This is Event Builder, and hit open, and I'm going to look at my working directory, and then I'm going to open the test a cell. So test a cell is that straight line acceleration that I ran just a minute ago. So I'm opening that, and here is let's do a side-by-side comparison. Full vehicle, straight line events, acceleration. These are, and I'll just type it. I'll type something here to make it not angry at me. So these two events, let me just sort of cover this up so it's not confusing. So these are the same event, right? On the right, you have the simplified CAN event, which looks like it has like 12 to 15 options. And then over here on the left, you have like the full access to the event. So I got a bunch of tabs up top, and I got a bunch of tabs. So in the bottom, I have a tab for every single control in the vehicle. And then up top, I have a tab for static setup. So earlier I was talking about there's 5 different types of static setup. Here, it infers what type of static setup to do. But in here, I could change it from I could tell it to do a normal setup, and then a normal setup is just the thing. It just lets it settle on the ground, and it won't let it you'll have to come up to speed. You have to drop the clutch and shift into gear, and you know, in runtime, which might be something you want to see happens. And so this is where you change it to that. The thing for this, so one thing is like gear, right? I just did a straight line acceleration analysis, but for, you know, for whatever reason, it don't let me, you know, it doesn't let me shift gears here, right? I can't tell it to shift gears. I don't know, I don't know why this isn't an option for this dialog box. Maybe it should be, but this is a good learning example in that you got to remember that these canned events are just simplified version of this event builder event. And so I'm going to make a single change to, I'm going to put this back to the straight setup. And I'm going to make a single change here. I'm going to go to the gear control, and I'm going to change the method from open to machine. Now, remember I told you machine is, again, machine is a synonym with test rig, which is a synonym with the driving machine. Machine means closed loop, right? Pretend like this is open, this is closed. Closed loop means just, you know, give it, do what you think, do what the machine thinks it should do. And then I've already said, you know, floor to throttle. So what the machine's going to do, so throttle, you can see starting at time equals 0.1. I do a 1 duration application of the throttle to a final value of 100%. And these values come straight from here, right? Because when I ran this event, it saved this file, test.sl.xml, to my working directory. And I just opened it. And this is what the same parameters look like in the event builder. And then I can even show you, what they look like in the actual XML that has been created. So test.sl.xml, I can open this in Notepad++, and this is the XML file. If you're not familiar, XML is open source markup language, and you know, it's all here. If you decide you want to externally manipulate this file with Python or something, you know, go right ahead. There are applications for doing that, or manually modify it. All that's fine. Obviously, you got to get the syntax right. But that is what is ingested by this tool. And so I said all that to say this, like I was in here, I got my straight line acceleration set up, but I wanted to shift gears and it didn't give me the option. So I go to the event builder and I change a single thing. I just tell it, I change it from open loop gear control to machine gear control, right? And I hit save and use. At save and use, it takes me to this little dialog box, which is the file-driven events, which this is basically like submit an XML defined event. So it's just like a stub version of the canned analysis. And this is found here in full vehicle file-driven events. And then if I test and I hit apply here, it will run that for me, right? And so if I look at these in the post-processor, I got these two events. So I got so one's called test-to-sell and the other one's called test-to-sell. And the reason I should have chosen a better name, but the reason because I put a test here and the file name also has test in it. So the test-to-sell is the one that I've modified. And then if you look at the something like the acceleration, because one shifts and one doesn't. Okay, so yeah, I think I flubbed that one. Not sure why. Let me look at the actual gear demand data and see if it changed. So it just stayed in second gear. Unfortunately, I have to take my word for it, but that the event builder is the tool for making minute changes to files and then changing the way they run. The event builder is an advanced tool in that there's so many options in here that it's easy to mess something up. I obviously did in this short example, but it's what I wanted you. The reason for showing this is to demonstrate that it's easy to come in here and think that these canned analysis is all there is. But there is a tool that gives you powerful control over the analysis themselves. And even this is what's called you'll hear this term mini maneuver. And so that's because the whole event is a mini maneuver, and you can add you could add braking. here as a second maneuver. So I could have an event that starts with acceleration and then ends in braking. And then I could even, like these settings, I could look at an actual braking event, and I can pull those settings, and I can make compound events and stuff like that. So just to provide you a broad context of what it's like to set up and run events in Adam's car, that is done in Event Builder, but you don't have to master the Event Builder. You have these can analysis to start out with, and the can analysis are how you should start out, but don't feel like these are like dead end streets for what Adams is capable of, because if you use Adams a bit, you will wind up in here setting these events up, and you'll be able to make it shift as well. So that is, I do have a slide on post-processing, which I don't think I have time to cover, but there's a slide here that does a really brief overview of the creating plots and post-processing. And I also have a slide in here that talks about scripting, and tells you how it also talks about, briefly talks about how to get started scripting. So if you use Adams a lot, you'll eventually want to script events, and because Adams could be a lot of button clicking to get through the different events, and you might want to run a series of like 10 events, so you can build a script. It's all pretty straightforward. There's built-in tools to Adams, and if you take a look right here, I got a little example of how I determined what a command was, and I put it into this little script down here. So as far as advanced topics, next session, if you guys show up at the same time next week, or access the next event in the series, you should see some talking about the template building, which is modifying the actual topology of the vehicle. You should hear some talk about tires, so fitting tires using a tire data fitting tool, using some example data that is similar to tire test consortium data. And the another topic, which is covered in some of the Adams training materials, which you can access on the Sim Companion, is Adams can also do flexible bodies. So this body looks like a FEA body. It's not quite a finite element body. It's something called a modal neutralization, but it's created by an FEA solver. And you have flexible components, and you can see their deflection and volume AC stress at runtime and stuff like that. Just wanted to briefly show that, and I'll let Alex take over from here.
Thanks, Joe. So I want to make sure that everybody knows how they can access our software and how they can find out more about how to use it. The student competition bundle is for free for all student teams that are doing really any kind of competition, not just Formula. That includes commercial grade versions of all of the software that's listed here. Quite a big selection. For you to be able to use Adams Car in particular, you want to use the student competition bundle. There's also student editions. Those are easier to get your hands on. You don't really have to go through campus IT or an application procedure. You just need to fill out a simple form, upload your student ID, and you get free access to the packages that are listed there under the student editions. That does include Adams, but not Adams Car. The student editions are limited in some ways in terms of how big the model can be, and they are just not big enough for Adams Car. But if you wanted to get something running on your machine in the next couple of days, the student editions are the easiest way to go. And again, if you're on a student competition team, it's definitely worth applying for the bundle. We have a couple more webinars coming up. Like Joe mentioned, we have one coming up this same time next week, going deeper with Adams Car. And then the week after that, we'll be having a webinar on finite element analysis and some other aspects of structures with MSc Apex and MSc Nastran for Formula. To get all the information on our webinars, to be able to track the whole series, you can go to the Sim Companion page that we have listed there, and I'm about to drop some links in the chat. So if you go there, you can find links to past webinars, you can find information, registration for upcoming webinars. If you want to, stay up to date on, when does the registration for the 6th webinar come out, the easiest thing to do is to just follow me on LinkedIn. Oh, I should say that when we record the webinars, we put them on YouTube. And so if you want to go back and watch previous ones, all you have to do is go to the MSc Software Hexagon YouTube page. Thanks. Thanks, Joe. Did you have anything more you wanted to tell us about, or should we just get into question and answer time?
Yeah, so I think I'm through with what I wanted to cover.
Okay, great, thanks.
Our SI units expected. Adams uses what's known in simulation as consistent units. So by default, it's going to be in SI, but you can change it to imperial. It should always you should never see a number that's like a speed and not know what the units are. There's probably some exceptions somewhere, but you should never have to estimate what the units are. If you're like typing an equation or something, you will know that your model is set to SI or imperial. And so if you're typing like a mathematical equation, yeah, it's going to be in whatever you have the model set to. But if you specify it, you can type in the actual units. It'll be like that's like an override in a formula. But in these little dialog boxes, it'll always ask. Does Adams support OpenDrive and OpenCRG? I'm not sure. I haven't gone over the set of roads and stuff we support in quite a while. There's a long list, but I'm not sure if we support OpenCRG. That would, I mean, a quick search. This hopefully got covered in previously, but if you just open Adams up and you hit the help and you hit the help here, it'll open up this searchable database of help. And if I type in open CRG, yeah, I mean, see, it says something about it, right? The open CRG road model. The curve. Okay, yeah, curved rectangular grid, which I have worked with that before. Yeah, it's a certain way to specify a surface, right? Yeah, so it supports it. There's also like if you just want to like make like a big like blog or something, it also supports a road that's defined. I call it a mesh road. I don't know what the actual name of it is, but it's like shell. If you go to simulate full vehicle, if you go to embankment, right? So like this is an example of a mesh road, and this aired out like this is like a jump. So you gotta set the parameters just right, or the vehicle like just fail. It like misses and it fails. Do I have it on session test? No, I don't have it in the session, unfortunately. But you can definitely get it to like hit this ramp just right and do like a flip if you want. But this file, if you right click on this RDF is like it's a simple 3D road, and it's just meshes, and you can see like visually what it looks like. It's just like a mesh. But if you look in here in ACAR shared, like if you want an example of something, I always look in ACAR shared. Don't assume that we've moved it over to the Formula SAE database. But is there a CRG roads? If I just edit this with Notepad++, this is probably it, right? It's a CRG road. It's probably open CRG, but you can just open this up and see what it looks like. There's a bunch of stuff in here. There's some binary stuff. You probably know more about it than I do, but yeah. There is any more questions for the fact session?
Yeah, here's a simple one. Do you recommend modifying the existing full car suspension, or should people be building their whole suspension model from scratch?
You should be modifying this. You should start with the Formula SAE suspension. It's pretty robust. It's been around for almost 20 years now, and it's not like if you were in Adams View and you were trying to build a 4-bar link or something, you should definitely start from scratch. And that's a good exercise to do stuff in Adams View. But in Adams Car, it has to be fully compatible to do full vehicle analysis. It has to be fully compatible with the full vehicle control rig. So building from scratch is difficult. I would definitely recommend starting with this model for if you're building a Formula style car, starting with this model, or worst case, start with some model that already runs and start modifying from there, one bit at a time. And there'll be a template modification example in the next session. So templates, when you're in Adams Car and you actually want to change the topology, we call that template mode. So you'll learn more about that soon.
I think that's it for questions for now. So Joe, thanks again for preparing this presentation and offering it. It's been very informative. And thanks to everybody who attended. I hope you find it helpful. Keep in touch and let us know how we can help you get up to speed with Adam's car and with other hexagon simulation software for Formula and for other vehicle competitions.